slope and rate of change. So our last lesson we talked about the rate of change. So now let's see how those two, slope and rate of change, are the same exact thing. So it says graph the line below on graph paper. The line should pass through this point and this point, so 0, 1, and 6, 4. Then draw and label 3 triangles on the line as shown. The triangles should be the same shape but different size. Make sure that each triangle lies on the intersection of 2 grid lines. Holy cow, that says a lot. So, but watch, I'll walk you through it, and it's not so bad. So, let's plot these 2 points, 0, 1, and 6, 4. So we know that the first number is x, the second number is y, and the x is your left and right movement, and the y is like the y in the sky, that's your up and down movement. So 0, 1, okay, is right here, and I'm going to label that. So we didn't move left or right any, but we moved up 1. And 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So right 6 and up 4. And now I'm going to grab my straight edge. So if you could grab your straight edge or, maybe the side of your calculator or the side of your agenda book, something that's going to give you a nice straight line connecting those. And I'm going to extend mine, and I'm also going to put an arrow on the end of it. Okay, that's going to keep going. It does keep going in the opposite direction as well, but I'm only concerned with this part of the graph at the moment. So now it says, make 3 triangles, the same shape but different sizes. So let's see, excuse me, how we can work that out. So I'm going to start here, and I'm going to make a triangle there. So there's one that's that size. And then let's see, I think I'm gonna change colors to indicate my second triangle. And there's one there. And my third one, let's see, what do I want to do? Oh, let's go this way. Oh, let's go over a little bit further because that one's the same shape as the one I just got done doing. So let's continue. Make a little bit bigger one, okay? So 3 different sizes. So why'd we do that? So let's see what it says. The triangle should be the same shape. Make sure that each triangle, okay, we did all that. Now it says let's complete the table according to our picture. So triangle A, let's call that our red triangle. Triangle B, that'll be our green triangle. And triangle C will be the blue triangle. So now it says, so let's focus in on triangle A. It says the length of the vertical side. The vertical is the up and down. Okay, so what's the length of that vertical side? Okay, it's 1. And then the length of the horizontal side that we just drew in is 2 blocks. So now it says the length of the vertical over the length of the horizontal, which would be 1 over 2. Okay, that was our rise over run. That sounds familiar. Now let's go to the green triangle and do the same thing. So the length of the vertical is 2, and the length of the horizontal, 1, 2, 3, 4. And let's do that same fraction, 2 over 4. But we know that we could simplify that fraction 2 over 4 to 1/2. Okay, and now let's do triangle C, our blue triangle. And let's do the same thing. The length of the vertical side is 1, 2, 3. Okay, the length of our vertical side is 3. And the length of our horizontal side is 1, 2, 3, 5, 6. So vertical is 3, horizontal is 6. Vertical over the horizontal, again, we could simplify that to 1/2. So it says, what do you notice about the last column of the table? Okay, they are equal. Okay, so the slopes are the same. Okay, that's our slope. Okay? So slope is our vertical divided by our horizontal. In other words, that's our rise over our run. That's where rise over run comes from. That's just a nice little way of remembering it. So the slope formula is, okay, our rise over our run. Or in other words, we could say the change in the y value over the change in the x value, okay? So nice, easy way to remember it, rise over run. Now we're getting a little bit more mathy, a little bit more algebra involved. We've got our variables involved, our change in our y divided, whoops, I forgot an e there, divided by our change in our x. I'm going to take it one more step and continue to make that algebra. And we're going to practice it. Y2, and that's a little subscript, minus y1, that's another little subscript, meaning it's a number that's a little bit below the line, divided by the x2 minus the x1. Okay, this is the same thing as these two things. This is just a little bit more involved, okay, but they're the same exact things. And now I'm going to simplify it one more step and introduce something. It looks like a triangle, right? Change in, it's red, the change in the y over the change in the x. I always say mathematicians are pretty lazy. We don't like to write the words. We like symbols to represent the words. This right here, this triangle, is a Greek letter delta. A Greek letter delta. And delta in math means change. Okay, so the change in the y values divided by the change in the x values. These are all ways to calculate, to remember, to figure out slope. Okay, and we'll talk about all of these as we go through this chapter. Okay, so we're going to find the slope of each line on our examples here. Okay, so we've got some graphs. So just like the example that we did here, so let's pick 2 points. Any 2 points, because remember, we could pick different points and still it's going to come out to be the same. Whatever triangles we make on there, we're still going to be able to simplify and find the slope. So I'm going to rise up and I'm going to run. So my rise, my vertical change is, 2, and my run is 1. So my change in my y value divided by my change in my x value is 2 over 1, which then just simplifies to 2. So the slope of that line is 2. All right, let's look at this one. So now we had one like this on our problem set 4.1. Well, this one here is going up and to the right, because remember, we read left to right, so it looks like it's going uphill, and we came out with a positive number. So this one, because when we read left to right, it's going downhill. So our slope should indicate that it's going downhill or decreasing. So our slope should come out to be a negative number. So let's see exactly what happens here when we think about our change in our y value over our change in our x value. So let's do, here's my vertical. So I'd be going up 1, 2, 3, but I'm going backwards here. So I could say I'm going up 3, but I'm going back 1, 2, 3, 4, going back. So my change in my y over my change in my x is going to be 3 over negative 4. Now I can't simplify that anymore. Another way to think about it is we could do the other side of the line, but we're still going to come out to be the same thing. Okay? So my rise over my run, okay, is still going to be, and you've got to recognize that that's still that negative number, all right? So if I go from here to this point, I would go down 3 and right 4. So still, negative 3 over 4, these two are the same things. It doesn't matter where the negative is, okay? That's still a negative 3/4. Okay, or 3 over negative 4. Those are equivalent. They're the same exact thing. Okay. Wow, what's going on in number 3? Okay, what's going on in number 3? Now let's change here because this one's a little odd looking. If you just sit and think about what's the slope of this line, does this line have any steepness to it? And hopefully you could say to yourself, no, this line doesn't have any steepness to it. So what would be your prediction that the slope of this line would be? Hopefully your prediction is if there's no steepness that the slope is 0. Okay, so let's prove our prediction. Okay, let's see if our prediction is true. So I've got these 2 points on my line. Okay, and if I go from point to point, do I rise up any to go from this first point to this second point? Okay, I'm not rising up any. So if my rise is 0 divided by, what's my run? 1, 2, 3, 4. 0 divided by 4 is 0 divided by anything. Type it into your calculator if you're in disbelief and see that it's going to be 0. Okay? So a horizontal line will always have a slope of 0. Okay? Always have a slope of 0. Another little trick here. Okay? 0 slope. Okay? A Z. Okay? Looks like that. Z for 0, and what does that Z have? It's got these nice 2 little horizontal lines. Okay, so the Z for 0 and the horizontal lines that make up the Z, hopefully that might help you remember that a horizontal line has 0 slope. Okay, and whoa, what about this one? Okay, now we've got this vertical line. Okay, we've got these 2 points here. Now, what would be your prediction for this one? Okay, so this one might be a little bit different in our thinking. So it's vertical, so it's not the same as this, so we can't say that it has 0 slope. Well, let's play around with our change in our y over a change in our x, or a rise over run. So let's go from point to point. How much do we rise up? We rise up 1, 2, 3, 4. We rise 4, but do we run at all? Do we run? Do we go left or right at all from point to point? We don't. Holy smokes. 4 divided by 0, type that into your calculator and you're going to see that the calculator is going to give you an error message. Can you divide 4 by 0? You can't. It's not possible. So this, okay, a vertical line is going to have a slope that is called undefined. An undefined slope, okay, or no slope. It's not 0, okay, it's no slope. So a vertical line will always have no slope. And a little trick to remember vertical line, no slope. Let's draw an N for no. And what does the letter N have in it? It's got 2 vertical lines. Maybe that N and 2 vertical lines will help you remember no for no slope of vertical lines. Okay? So when I see you in class on Monday, I want you to come in with a sticky note. Okay? And don't tell your friends if they don't do the video. Sorry, phone's ringing. I'll pause. I want you to come into class with a sticky note with a Z for 0 slope in a vertical line, and an N for no slope. Oops, I mixed up. A Z for 0 slope for horizontal line, and an N, okay, for no slope for a vertical line. Come in with a sticky note with those 2 things written on it. Don't tell your friends, okay? That's going to tell me that you watched the video. So when will the slope of a line be positive? Okay, a slope of a line is positive, okay, when the line is going uphill. From left to right, okay, because remember, we always stress working our math from left to right, just like we read. All right, so then when will the slope of the line be negative? When the line is going downhill from left to right. Okay. Okay. All right. So now, whoops, sorry about that. This next, it says determine the slope of the line. Oops, I don't know why this keeps moving. Apologize. There we go. That passes through these 2 points. So now we don't have a graph to look at and find our rise over run. So we're going to use our formula that I wrote on the first page. That's our slope formula. Okay, when we don't have a graph to look at, we still can do our calculations. So my first point, here's my x1 and there's my y1. And here's my second point, so that's my x2 and that's my y2. I don't know where those random lines are coming from. Something's acting a little funky. So let's plug those in. So my y2 minus my y1. My y2 was negative 10 minus my y1, which was negative 5. So I'm going to put a parenthesis around that negative 5. All divided by my x2 minus my x1. My x2 is 7 minus my x1, which is 2. So now we've got to do some mental math here. Use your calculator by all means. Negative 10 minus a minus 5. Negative 10 minus minus 5, that becomes a super positive. So that's a plus 5 all over that 7 minus 2. And now let's take this last step. That's going to be negative 5 divided by 5. Can I simplify that fraction? I certainly can. So the slope is negative 1. Okay, let's go ahead and we'll do maybe one more because we are definitely getting a little bit long here, okay, in our video. So let's hop down to number 9, okay? So again, let's do our slope formula. We're going to use that formula because we're not given a graph. So it's not as easy to count. Okay. So, and let's label x1, y1, x2, y2. I don't know why those black lines keep coming out here. Oh, goodness. Oh, my goodness. It has a mind of its own today. There we go. Okay. Okay. So I think I need to do these videos in a bubble, and then there's no noise. So my y2 is 8. My y2 is 8 minus my y1 is 8 as well, divided by my x2. I'm going to go back to my second point in the x value there, negative 9 minus, and then my x1 is a minus 7. Now let's simplify. What is 8 minus 8? 0. Negative 9 minus a minus 7. Ooh, there's that. It's going to become our super positive. So negative 9 plus 7. Let's continue to simplify. 0 divided by negative 2. What's 0 divided by anything? That is a big, fat 0. So the slope of that line, if we were to plot those 2 points, and the slope was 0, what kind of line would we see? You should see a nice horizontal line. Okay? All right, we will practice more in class. By all means, try number 8, try number 10. Like I said, the video is getting a little bit long, so we'll pause there. And we're going to work on 4.2 in class on Monday.